I'm Matt. I work for a company called 7Digital, and I'm going to talk to you about how we, about the evolution of our API over the last few years. So, first of all, a bit about what we do. We're an open music platform. What we enable is companies and developers to build music applications. These can be all kinds of applications and all kinds of people, from small bedroom developers who just want to make a fun application, up to mobile phone companies, streaming radio services. We have got rights to music in 37 territories around the world and 22 million tracks. Now, if you wanted to build all of this music infrastructure yourself, or particularly acquire the ability to sell or to stream music all around the world, if you were to do that on your own and just employ some lawyers to go out and do all this for you, it would take you a year at least before you were able to legally do that in all these different territories. Whereas with us, you can sign up to our API. It's free to do that, and you can build your application or your store or your radio service, and you can start. You can put it live as soon as you finish building it. We've always done business-to-business stuff through our API, but we also have a consumer service, which is just selling direct to individuals. But as this is an Nordic API, so I'm going to talk about our API and how that's evolved. So who uses 7Digital? We are used by, well, all these people and more. There's a couple of points to make here about the sorts of requirements that our consumers have. One of them is that good reliability, but that's the same as anybody, right? Everybody wants to have a good, reliable service, but maybe something that's a bit more pertinent to the talk I'm doing is that they require consistency, and so many of these people are building applications that run on not even smartphones, possibly quite dumb phones. So if they're coding against an API, the API you can't just change it and go, okay, you go and sort it out. Maybe they can't actually update the applications that are in these devices. So as well as phones, it's even things like we did actually have a manufacturer of fridges was putting music players in the front of their fridge. So they can't just click update application and it will all be fine. So yeah, things like breaking changes, something that we can't really do all that easily. So I'm going to talk a bit about where we came from with the API. So in the very early days of 7Digital, we actually didn't have an API. We still had a business-to-business component to what we do, but that was kind of built around making white label websites for third parties that used our sort of services in the back end. So we actually started the API as kind of as a side project, or as a project for a specific customer that we had at that time. It was written kind of as a single monolithic application, using the same shared libraries as the website that we had at the time, and we did it in C#, and we even used web forms, which was pretty awful for doing XML responses, but that's how it happened. And yeah, as I said before, this API kind of used all the shared infrastructure as the website and all the other applications that we had. And we also had a single team developing the API called the API team, and they did everything to do with the API. Here's an extremely complicated sort of architecture diagram. I'll just give you a moment to digest this. So here's the API. Here's some sort of data store, database, and here are all the people who are developing the API. as you can imagine, this caused us some problems. So, of course, as soon as we got one customer using the API, we then found that more people wanted to use it, and we kind of started to get quite a lot of momentum with people using the API, and we found out that maybe more people would rather build things themselves or build mobile applications or things that required the API. And we ran into a lot of problems. We're still running into them. So the dependencies between the API and the other applications that use the same shared libraries. This is a big problem to keep everything updated. Like you have release a new version of some component, and you have to fan that out to the API and to the website and to the internal applications, all these things. Having a single API means that you have a single code base. That's very difficult to work with because somebody maybe wants to make a change in one part that's to do with, I don't know, purchasing music, and then somebody wants to make a change that's related to some other quite unrelated part, but they're kind of tumbling into each other with changes that they want to make, and somebody has to wait for one person's change to be completed before the next one can do their change. And how do you scale the API? And by that I mean sort of two types of scaling. The kind of technology scaling, how do we make this more available? How can we make it handle more load? Obviously, we can do that, but you have to scale everything at once. Just maybe the load on one part of the system is going up massively, but the other part isn't. So you have to kind of do everything at once. And then kind of more importantly, I think, how can you actually scale the development? How can you add more developers to work on the project, to add new features when they're all having to work on the single application? It's very difficult. So as it kind of became apparent that sort of selling the API to consumers was going to be a big direction for the company to go, we had to really work out, we really need to do something about this, and we need to kind of at least have a direction in which we can continue to expand without the problems that we'd been running into. So the approach we took was to, first of all, add a routing component to the original API. So what I mean by that is, this is kind of illustrated here. This is a URL to our API, provides information about a release, like an album, something like that. And it's identified by the release ID here. But really the important information here is that it's this API endpoint, release details, tells you details about the release. In the original design of the API, the whole monolithic application, this was done by an ASPX web forms page that would call down into all the shared components and the shared domain, and eventually get to the database, find the information, and bring that back up to the HTTP response. So what we did is, for all these different endpoints, we added a component that could decide whether this endpoint was going to be served by the original code, or whether it was actually just going to make another HTTP request to another API, this time an internal API that's only accessible from within our network. And we started to build very slowly some internal-only APIs that just were built around specific functionality. So, for example, the catalog here. This is asking for a specific release in our catalog. So we have a catalog API which is internal, and this original API, the monolithic API, can just delegate that request into the catalog API. And all the things that this thing has to do, many things to do with authentication and what have you, logging, caching, whatever. But all this thing needs to do is know about how to find out what this release is. That's it, quite simply. So we started to build these internal APIs around different functionality. So then at this stage, we kind of had a vague strategy or a vague idea about how we were going to solve some of the problems that we were encountering. So we kind of had to go about doing it. So as I said before, we would gradually move code from the monolithic API into an internal API. And this allowed us to, in some cases, rewrite the code, or in some cases we didn't rewrite it. We pretty much just took a copy of the old API and put it inside. So more or less the same code running in two places, but the original code was still delegating. So that way we could maintain the same behavior because it was the same code, it's the same application, although running in a different place. This is a slow evolution. So sort of one by one, we moved endpoints like this. We probably have, 30 or 40 or 50 endpoints. And we could move them independently of each other. We actually have an internal application that allows us to manage where endpoints are pointing to, like whether they're sort of this API or that API, or whether they're still in the monolithic API. So by doing things this way, we didn't ever have to do a new version or just a big release where we hit the button and hoped everything kind of worked okay. We could move things piece by piece, and we could make a testing version of a testing version of an endpoint that we could test internally, and then move the real endpoint to point to the same place. And this enabled us to make quite big changes to architecture without really our consumers ever seeing any change. They didn't even know that this was happening. So here's a slightly more complicated, or slightly more representative now of diagram of the way 7Digital API works. So this thing here, we now call the monolithic API the router, but this is not a new component. This is the same code that's been running since the dawn of the 7Digital API. It just happens that now, after we've kind of moved most of the actual functionality into these internal APIs, that really all it does is route requests from the consumer, the application, mobile phone application, or sort of third-party website, through our infrastructure and to the appropriate internal API. And this still deals with some of the kind of cross-cutting concerns that everything in our API has to deal with, like logging and authentication, OAuth, permissions and things like that, request limiting. But now we have these very sort of focused internal APIs that are built around a specific functionality, kind of a logical grouping. So search is different to catalog, for example. Payments is its own thing separately. And I suppose our kind of ultimate goal is that there will be no sort of code related to what we actually do as a company left in the router, but we still haven't quite got there yet. There's still maybe a few endpoints still running on the original code that we had. So this gave us quite a few advantages in what we were able to do technically. So first of all, smaller code bases. Each of these internal APIs, even when they were just a copy of the original monolithic API, as soon as you copy it and it only has to do 5 things instead of 40 or 50 things, you can just start to delete code. It's really fun. You can just go like, oh, that's not used anymore. And you see all the code and all the dependencies that are not related to that particular area just disappear. And it's like the most brilliant refactoring in I don't know if you ever use ReSharper. You can just hit Alt-Enter, delete, 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 and it just deletes all the code that you don't care about, which is great. It also means that the technology that's used between these internal APIs can be completely different. So this could either be quite a small choice, like which web framework am I going to use, or it could be something that's much bigger, like running a different language or a different operating system, a different data store. Also, everything is much easier to test because it only really does one thing. If we go back to here, the release details, I don't have to populate all the data that's needed to make the API run just to test whether this release is displaying correctly. All I need to do is populate this internal API with some test data and check that that's working. So that's much easier. And we still keep the monolithic API there, although now, as I said before, it's kind of like a router. But to test that stuff, all we need to do is test that this request goes to this internal location and that all that part works fine. I don't need to worry about that location internally doing something. It can just sort of be an echoing endpoint or something like that. So as well as quite a few kind of technical benefits that we found, we also changed this evolution, led to quite a big evolution in the way that we work as a company. So we can start to build teams around the internal APIs. So, for example, here we have a team, after we split out the search API and the catalog API, we then built a team around those two pieces of quite related functionality. Each API exists sort of internally as its own product. So they have a product manager, kind of like the answers to the other parts of the business. And work items are much smaller because they're only concerned with one particular API. So this is not all good. There's a lot of problems that come with this approach. The APIs, there's nothing really governing the APIs being consistent with each other. And by that I mean like having the same format for responses or having the same, sending out the same headers or something, for example, like that. With the kind of focused teams, there's a risk that developers only know about their specific area and you get a lot of knowledge building up, which obviously isn't good when people leave or somebody has to deal with an area that they don't know about. People only know about their internal product. We've lost a lot of dependencies in code, but we've added a lot of kind of implicit dependencies because now we have this sort of loosely coupled structure. There are dependencies between APIs, but they're just dependent on different HTTP calls and responses coming back. And just overall, just more chaos with this kind of loosely coupled SOA-ish sort of architecture. So first of all, I'm going to kind of go through these in reverse order. How do we limit the chaos? First of all, again, smaller APIs are easier to understand, just because of the nature of there's less going on to understand. You have request and a response, and the request has to conform to a certain format for it to work, and you can test that that contract is obeyed. So that's easier. We invested a lot of time in a continuous delivery and being able to deploy internal APIs really easily. And what that means is that you don't necessarily know that the change that you're going to make to, say, an internal API is going to work, because there's all kinds of eventualities that even with the best QA and testing, you can't capture all the kind of silly things that our consumers are doing. But at least if you have easy deployment and good monitoring and metrics, things like StatsD and New Relic and Logstash, we at least know when things aren't working as they're expected. And if we can deploy something and roll it back, then that's okay. We can test things in the real world without having to, knowing that we can come back from them without too much interruption. And the other thing that we do is we build all our own applications. We have our own mobile phone applications and our own web store. They are now built almost exclusively through the API that's available to our customers. So this kind of lets us find problems before our consumers do. So how do we keep consistency between all the different internal APIs? It's like we don't have a defined way to do it. We just do it by good QA and testing. I think Matty's talk before lunch was very pertinent to that. We kind of tests are a form of documentation, and we write tests for new functionality up front. And we also have a schema, a single schema, which is an XML schema, but it also applies to the JSON responses. And we make sure that people who are developing new API endpoints conform to this schema. So how do we avoid building up these knowledge silos? So one way to do this is that although we kind of have these very focused internal APIs, sometimes a feature that we need to add means that changes have to be made across 2 or 3 APIs. And when that happens, we use the opportunity to do pair programming between teams. So maybe somebody working on the search team will join the payments team for a little while to help them to implement whatever they need to do, or vice versa. And we also kind of allow people to move between teams, even if it's just for a week, just to see what they are getting up to, or a more kind of permanent move. And we also organise knowledge sharing sessions. So this is maybe one team has been kind of trialing out, I don't know, a different web framework or a different data store. And if they think that that's interesting, then they'll just informally arrange, maybe on a Friday, an hour to go through it and discuss how this could be useful for the other teams in 7Digital. So that's about all I've got to say. But I'd be interested if you have any questions or any comments I can help you with.
So how many versions you have to maintain in a single internal API? Versions.
Versions. No versions. We don't tend to really version anything at all. I think it's kind of been discussed that we might at some point. So you were possibly a bit confused. There is a version number here from back in the days when we thought we may release another version, but I think we've decided that it's always going to be that version. And it's difficult because it means that breaking changes are very difficult to do. We have to kind of engage with our consumers and, talk to them over many months if you ever want to make a breaking change. But usually we don't actually have to do that. You can kind of add, if you want to add data, that shouldn't be a problem because people should be using proper XML parsing. So adding a new field shouldn't be a big problem. So yeah, in general, we don't ever have to do versions.
Going from a monolithic application to more of a distributed application, do you have any problems with performance and stuff like that?
Yeah, certainly.
And how do you cope with those?
Just try to make things faster, basically. I think having good metrics and good monitoring is half of the problem is actually finding out where the performance bottleneck is in the first place. And then you can kind of take steps to try and fix them. Caching can help quite a lot, and sort of trying to be quite intelligent about how you cache things, because especially in what we do, a lot of our stuff is very kind of heavily cacheable. And kind of having this sort of structure makes fixing performance difficulties a bit easier, because you're not reliant on everything using the same data store. So we use Solr now for search, and it means that each of these things has probably got quite different performance requirements. So you can use the most appropriate technology without really impacting anything else. Does that answer your question?
Yeah, you mentioned that you had new problems with implicit dependencies, for example, for XML formatting or data structure.
Yeah.
Do you have any best practice to handle that?
Not really. We're still learning quite a lot. Having tests that run kind of black box outside-in tests that run against the real system is very useful there, because you can make sure that everything's wired up correctly, with all these different internal APIs. So having tests that run end to end and perform, multiple steps is important. And although we kind of have these sort of teams that are quite specific to the products that they work on, the QA and the testing, although they're kind of maybe loosely associated with the team, they move around between all the teams. So they're very good sort of vectors for, I guess we don't really call it like best practices. We sort of.
Okay. But you also mentioned that you're adding new fields to the XML. Is that something that you kind of do freely? Or is that kind of documented as well and need to be synced among all the teams here? Or is it something that one team can use?
It's documented, but it's not something that would normally cause things to break, because normally it's removing things or changing functionality that causes things to break. Just adding some more data is a kind of additive change that most people should be able to cope with. So.
Okay, thank you very much, Matthew.